Hello, I want to take us through time series analysis using Stata. I want to say something about the first set of things to know about time series before we talk about using Stata for the analysis. See, analyzing time series in Stata is a valuable skill, especially when working with agricultural data, where trends and patterns over time are important. Here is a step-by-step guide to help you teach your student if you're a teacher how to analyze time series using Stata. So we load the data. Then even before we continue, what is time series? Time series is a data set that occur with a regular interval of time. Time can be yearly, can be weekly, monthly, quarterly, even hourly. So we now load the data. By loading the data, so it's either we import or we type, or we can use the built-in data available in Stata. I'm talking about agricultural data. It may not be agricultural data. Once it appear at regular interval, it is time series data. So using it, the first step is to load the data. Second is to check the data. Now, how do we even bring the data in? If I want to advise whoever is going to make use of Stata for analyzing of time series data, before you can use this command, use, you must have created your own directory. See, this is Stata. You want to create your directory. The default directory is here. This program file where Stata the setup is. But it's advisable we change your directory. Change directory. You can see change directory. You now look for where you want to use it. For directory, I have one directory here. If I click on this, it will change it. You can see it has changed to my directory. So in this directory, I must have loaded everything I want to do inside the directory. All the data set I need, information I need must be there. That is when this particular command can work. Use agriculture.dta. DTA is the file extension for Stata. So the next thing is to check the data. We should be able to check the data, and that is very, very important to examine the structure of your data set to understand its variable and time dimension. Very, very important. You know, there's no time series analysis without time. We must be able to describe the time. So I just type describe to give us whatever the information we need on that particular data set. Next one is time series plot. We should be able to plot it to see to understand the trend. The outlier we know, and the command here is ts set. Ts is time series set. Then you need to set the time variable. So by putting the time variable here, time variable here is maybe I can call it year, can call it hour. It depends on the time time series data is using. So we can now go to stationarity check. Stationarity. So how do we check for stationarity? What is even stationarity? If it is stationary, if properties of such data has not changed over time, just according to the name. So if it's not stationary, it means some of the properties of the data are changing over time, like the mean. So if the mean is changing over time, maybe from January to March, it maintains a particular value. From March to June, it has changed. That is not stationary. And we can't just visualize, though there are ways we visualize that, but it's not widely acceptable. So it's better we test for it. And one of the tests we use in carrying out stationarity check in time series analysis is Dickey Fuller. This augmented Dickey Fuller. So this is the command. If you're using Stata, put a variable name. Assuming I'm using GDP, I put GDP here, Dickey Fuller. Then if it is not stationary, we need to difference it. Yes, it's one of the solutions to non-stationarity or unit presence of unit root. Somewhere here. Let's see. If it contains unit root, we say it is not. Is it? Use the augmented Dickey Fuller ADF test or other unit root test to assess stationarity. So if it contains unit root, we need to difference it. So, and this is the formula for differencing variable. So it just removed, depends on the lag we are using. The first variable, the first observation minus the second observation. So whatever value you get there is difference value. So that was called differencing. You can do it automatically in Stata. Doing it manually takes a lot of time and there may be error. So if you want to do that, it's very, very easy in Stata. We generate another variable called diff var. That's a variable. So the autocorrelation and partial autocorrelation function, we call this one AC and PAC. It comes like a diagram which visualizes, the AC the variable name, PAC the variable name. We give us visualization of the autocorrelation and partial autocorrelation of the particular variable. So you can say you can analyze autocorrelation and partial autocorrelation function to identify potential ARIMA models. ARIMA model is an autoregressive integrated moving average model. So we use this to test it, and this, what we need to specify some orders here. Some values will be here. The P here is coming from the first AR, that is autoregressive model. D here is differencing. If we have difference, maybe is 1, we put 1 here. If the other is 1, we put 1. Then Q is the moving average aspect. So at times some data sets can be, or some series can attain stationarity at just 0, 1, 1 or 0, 1, 2 or 1, 2, 3. It depends. So we spend a lot of time here in trying to get the order that will give us stationarity on our data. So this is the command ARIMA variable name, then put it here. Now you can replace this with the order, as I've said. Then the next one here is after we have gotten stationarity, because a data set that is not stationary cannot be used for any forecasting. If we use that, it's not going to be reliable, and that will pose a problem to our model. And then what is the use of a model that we are used to forecast or make prediction without having a sense of reliability on it? So we have to be very careful here before we move on to forecasting. So we use the fitted ARIMA model to forecast future values. So the fitted means you have already obtained the good model. So specified number of periods ahead. For example, now after I've obtained my stationary ARIMA model, maybe at order 102 or whatever, so it has become my model for prediction. It's the fitted ARIMA model. So I should be able to now use it to forecast future values, and those future values must be reliable. So I will now put it there, number of periods. So for example, this year now, if I want to, if it's annual data, I can predict for another 6 months by putting 6 here. And if it's annual data, by putting 6 years, will give me another 6 years. If it's monthly data, I put 6 years, it's going to give me another 6 months. If it's quarterly, it's going to be another six quarters, and so on. So we can now evaluate our model performances. Very, very important. We must be able to evaluate it by using error metrics. We call this error metrics, such as MAE, MSE, RMSE. So all of this will give us the minimum year. If I have maybe I have 4 or 5 or 3 or 4 models, different orders. If it's 101, if it's 022, there are different models. Now, how do I know the best model here, or in terms of model performance? The one with the lowest or the minimum value from all these metrics, I will pick as my best model for forecasting. Then we have some other things I want to show to us, and those are the forecasting tools and tricks. So if I want to change, I want to generate another time series, I want to change the date, these are the command we normally use. I will drop this for anyone who want to go through. It's part of those things I've mentioned in the lecture. The subsequent video I will show us how we go about the analysis in detail. Thank you.